All right, well, I'm excited to introduce you to Morgan, be presenting on transparent multi-agent AI. And the floor is yours, Morgan.
Thanks, Melody. So hi everyone, I'm Morgan, Morgan Senechal. I'm a professional services consultant, principal consultant at Neo4j. And I've been working for Neo4j for 6 years now. So a bit of obviously context about me and what we're going to do in this session today before we dive in. Obviously in the past few years, couple of years maybe, I've started to work a lot obviously on Gen AI applications, like everyone probably here on this call. And we started a lot with using models to have some vector embedding and vector search similarities, you name it. And then obviously we started into the agentic system approach and all of that. Now, lately, obviously, what we see a lot at customer implementation and solutions is to use multi-agent systems. And the main purpose is this because obviously, if you think about it, when you have your application, Gen AI application, you might have an agent and that might work well. But for large enterprise customers or on customers where you have like lots of different data coming from different sources with some requirement on reasoning or these kind of things, multi-agent is usually like the way to go because you will want to have not just one agent with multiple tools, but you will want to be able to access data for different agent, specialized agent on different domain, industry, or even data, basically, right? And what I'm going to show you today is kind of like an implementation or a solution with a bit of a framework so that after this call, you can just grab the framework and you can reuse it, you can play with it, and obviously you can customize it and plug it and play with your within your data environment and all. But the idea really is you're going to see there are some challenges with multi-agent, and I'm trying to cover them with that kind of framework and solution. So what we're going to see today, so I'm going to talk about the challenge and goals of multi-agentic system as obviously being a part of professional services at Neo4j. I do lots of deployment in production, moving basically POCs, POVs, and all, the fancy wow effect that we see quite fast at customers, but trying to move them into production. So something that they can actually use and also something that they can get value out of it, right? As I said, there are some challenges and some obviously issues with multi-agent if you're not careful on your deployment, especially when we talk about production. And we're going to cover that. And then I'm going to talk a bit of the target and audience of this solution and framework, because obviously it's not going to fit for everyone, but it's going to fit for, I'm trying to make it fit and work for everyone, right? So let's see. And then the solution and the demo. So basically, I'm going to give you access to all the code, the repository that I'm going to use and demonstrate here. So you can just take it back home and you can just work and play with it, as I said, on any database you want. And a small demo just to show you how it looks like. At the end of the session, I'm also going to try to keep a few minutes for Q&A if you have any questions. For the audience now, so as you can see, the main audience this framework is for basically all three kind of key personas. You have the developers, the security legal team, and then the user stakeholders, right? And why I do have this kind of like three key personas is on the left, you have the developers. What this framework is going to try to help or improve in the multi-agentic systems, right, is basically how you can troubleshoot, how you can debug your accuracy, your response, what happens when you ask a question, how the data is being retrieved, and all that. So basically the kind of like traceability, logging, monitoring of your application. So that's something for obviously the developers that are here in this call. For the security legal key persona, this is because you're going to see with this framework, you obviously, as you start logging and monitoring your multi-agentic system, you will have access to a lot of data around what has been accessed, when, in terms of data. The whole basically workflow of things are going to be traced and logs. So you can start to have this kind of use case where you can have an audit and traceability on your data. And when I say data, I mean obviously the data, the documents, all the entities that have been retrieved to generate an answer from the multi-agent system. But not just that, you can also obviously have an audit on who asked what question, what the question, what agent has been triggered. You can obviously look at metrics on usage tokens, cost. So what was the cost running on different prompts or different models, and doing some evaluations on your application. And then the user and stakeholders, obviously, on the right side is because obviously that's going to give you source reference. So out of this solution or framework, you're going to be able to understand when a response has been generated from the multi-agent, which sometimes is usually quite tricky because you think about it, right? If you have a single agent, you open ChatGPT, you just ask a question, it's going to fetch some data, make a response. Easy. You have the source from this agent where the data has been retrieved and all good. Now, if you think about it, if you have your in-house multi-agent system, in-house built multi-agent system with dozens of agents, and each agent would have dozens of tools. If you don't have this kind of strong framework for like the audit and traceability, you're going to have a really hard time to understand what part of the answer, so if you have a really long answer, what part has been generated or basically is coming from which agent calling which tool. And yeah, it's going to be quite difficult to understand where is the response coming from. So that's the last part here. Now, talking about the challenges and the goals of like why I've done this framework is basically because what I was saying earlier, right? If you try to implement a single agent system, just like single agent, even with just like a couple of tools, right? Basically, it is hard to debug and troubleshoot, doing the evaluation and understand how the answer was formed, even for a single agent, right? Because it's doable. There are plenty of framework that you can use to do that, but it's not like just super trivial. You still have to go through a lot of steps to be able to have that. So imagine that multiplied by the number of agents. It's even harder because you have so much more to think about. In this list of bullet points, you can see, for example, I'm talking about agent-to-agent collaboration, which is basically where you have multiple agents being able to talk and communicate and collaborate between each other. You obviously have the flow of reasoning that you can't really see. So what agent has been called for what part of the question, for what data, what tools, and all these kind of things. Obviously, it's multiplied by the number of agents. So the more you have, and obviously comparing with single agent, that's way more complex to visualize. For the tracing, logging, and troubleshooting, as I was saying, obviously, you're going to see in the next slide, I do have a screen. What I was saying is there's already like some system in place. Think about LangFuse, OPIC, Langsmith, and all. You already have some frameworks to do some tracing, logging on your agentic systems, right? The issue is right now, most of them are good because they do have like really strong integrations, but usually it's just represented as a large dump of logs, basically in a table view. So it's quite hard to read or understand what is happening behind the scene. Now, the next point is quite important to me as well, is the repeatability. I don't know if, I'm pretty sure everyone on the call already tried, but if you go over to ChatGPT, Claude, or whatever you want, ask the exact same question 3 times, you're going to always end up with 3 different answers. The repeatability is never consistent, and what I'm saying here is really shaky, right, at best. And that's also one of the challenges I'm trying to cover here with this framework that you're going to see. And the last part, obviously, is lack of audit or like audit mechanism. So being able to ask for security or legal purposes, who accessed what type of document, who accessed what data, based on different questions, different agents, different tools, right? And so once you know, obviously, all those challenges, right? So the end goal of what I'm going to demonstrate today is really just to try to cover all of those challenges, basically. And today, I'm not going to talk about Neo4j as in how Neo4j can help you in the GraphRAG aspect, so the retrieval aspect, because I'm very sure everyone already know that. Everyone know how GraphRAG can obviously improve the retrieval aspect from giving more context and to generate a better and accurate response, right? So I'm not going to cover that today. Instead, I'm going to take the issue the other way around, and I'm going to basically show you how graph, and in this case, obviously Neo4j, can be used not for the retrieval aspect of your general application, but to actually orchestrate and manage and trace and log your whole GenAI application. So kind of like a layer on top of all of that. So what I was saying earlier, also if you look at current solutions, so there are some solutions, there are some frameworks here and there that you can find. You can see on the screen, I have an example, which this one was OPIC, but you can play with a bit with all the other LangFuse, Langsmith and all. They always kind of like similar, which is, in my opinion, they do a good job at tracing basically all the data, logging everything. They do have like obviously lots of integration with all current frameworks as well. So they can integrate with LangGraph, LlamaIndex, and LangChain, and all the others. But the issue is, if you think about it, when you think about, I want to know, based on the question, who accessed what document, what data, what agent has been called, what tool, by who, for what reason. This is nice. I mean, it does give you this information, but it's really hard and tricky because you need to like really drill down into lots of different inputs, tables, and all, and that's not really easy to read. I tried to take the problem the other way around. I was like, wait, if you think about it, the whole orchestration, so like what agent has been used for this question, taking the question, trying to break it into single subsets, single parts of the question, and what tools am I going to use, all of that. It's basically a graph, right? And so that's why I'm basically trying to put that into Neo4j. So I'm going to show you the kind of like key features here, and then we'll talk about the data model, and then we'll talk about the solution. So the kind of like key features that you're going to see here in this framework are basically what I'd already covered, right? The audit, the transparency, the workflow and memory, and the metrics. So for the audit aspect, you're going to be able to ask who accessed what document, how, why, when. If a document is confidential, you would be able to say, okay, show me the document, the confidential document accessed by this user, and these kind of things. For the integrity and transparency, so basically you're going to see out of the graph that we create, you're going to have basically all the logs of happening for every single agent. So you will be able to understand what agent input was provided to a tool, what task for that specific tool usage, what was the input, what was the output, and all of that is going to be obviously transparently stored into a graph. For the agentic workflow and memory, you're going to see basically, because we store the orchestration of all the agents and tools, and we also store the orchestration based obviously on the question, but also subset of the questions, you have this kind of like memory layer or repeatability that you can reuse for further questions. And I'm going to explain that in a second. And for the metrics, obviously, you are able to store all of that based on different runs. So imagine you want to run the framework on GPT-4o. We will obviously store all the information, like the execution time, the model, the tokens, and all of that, right, based on the orchestration. And if you want to change a prompt, if you want to change the model, so go with GPT-4, because then you want to compare and evaluate different models, how they obviously work, and what is the answer generated, what are the token, the time of execution, compare them together. Basically, you will be able to do that. So for the data model, so again, what's going to happen is you will have, out of the orchestration workflow, when you ask a question on your multi-agentic system, we're going to create a graph, right? And this is the kind of graph that we're going to create, basically, for that is going to be used for the orchestration, for the memory, for the audit, for all the part that we just talked about, right? So you will have a user here, which can be obviously your user from your chatbot who is asking a question, will have obviously the information on the question. The question will be part of a session. So obviously, up until now, that's really generic data modeling for any chatbot, even like a single agent chatbot. That's typically what we do. You will have a session. In that session, you will have question, and question would be attached to users. Now, the question can trigger an orchestrator. So that would be the brain. And the brain would use planner. The planner is basically, okay, I have this question. I'm going to break it into single parts. So maybe a 2 hops or 3 hops question. I'm going to break it into 3 tasks. So the planner is going to create tasks. And the tasks obviously are going to be assigned to an agent. So an agent will have an assigned task, and the orchestrator will call the agent. So agent, obviously, because it's going to be multi-agent. In this one, I'm going to show you 2 simple agents. And once obviously they do their work, they call different tools based on the task that they have. They can use input from a different result from a different agent. That you're going to see that because what I was saying earlier, we do have collaboration, agent-to-agent collaboration, right? And the task from an agent basically will produce a result. In the result, you will have all the information, so the token, the input, the output, all of that. The result. This part is optional, right? This is where you will want to use GraphRAG. If you don't use GraphRAG, you can just forget about this part, right? But if you use GraphRAG, so if you use some Cypher query, if you use some vector search on Neo4j plus Cypher hybrid text to Cypher, you name it, right? If you use any retrieval in Neo4j, basically, as part of the result, you will have this retrieval node, which is going to give you some information on, okay, what data has been retrieved from the Neo4j database. And so this obviously is quite dynamic. This is just as an example. But if you have the standard structure, which is basically a chunk is part of a document and chunk would have entities, this is kind of what you would see in your audit. Now, demo time. So for this demo, I'm just using the Needle starter kit. If you haven't seen it, I'm going to provide all the links in the slides. Basically, it's a framework, a starter kit framework that you can use to build front-end application. And as part of this whole front-end starter kit, which is called Needle starter kit, one component is a chatbot, basically. So you can just plug and play with a chatbot, which is this interface you see here. Now, obviously, I do already have a bunch of questions here that I'm going to show you, and I'm going to run an example as well. So you can see here, I do have my question, which does obviously have different different part of the question. I'm asking first how to run GDS analytics on Neo4j Aura, and then I'm going to ask how to generate an example to run a specific algorithm with a Python script, right? So obviously the answer, I'm not going to cover the answer in that one because I want to focus not really on the answer, but I want to focus on the audit and the whole framework, right? So obviously you have the answer here. But what I want to show you is basically this whole graph that I talked about, right? It's basically what we're going to represent here. So when I call the retrieval information, that basically means what happened and what did we use to generate this response. So it all starts here basically at the bottom where you have the question here, which trigger an orchestration. And the orchestration used different agents. So you can see for this question, I did use 2 agents, an LLM agent and a Neo4j agent. And obviously each one would have a result, what we were talking about. So in the result, you would have the description of the task, the input, the output, so basically what was the answer provided, the processing time, and all of this information. Now, what I was saying earlier is this graph that you see here, which is giving you all this information, is you have the visual representation here, but it's also stored as a graph because obviously it is a Neo4j graph. So I'm just going to show you that in a better way here, basically, so you can understand better. But it's basically the exact same data model we just covered, right? So you have this user here, Morgan, which is me. I did ask a bunch of few questions here. You can see them here. And the question obviously triggered the orchestrator, which is the supervisor. So obviously you have the time of execution as well, so you can trace that. And what I was saying earlier, right? Before even calling the agents, you have the planner, which in a sense is a different type of agents, right? So the planner is going to be like, okay, I need to plan and coordinate the task execution. This is my input. So this is basically the question, right? And what the agent or the planner is going to produce a result, and the result is basically a plan. So in this case, you can see the output, the generated plan. So you have basically the analysis, you have the strategy, so how I'm going to basically collect the data. You have the task breakdown. And in the task breakdown, this is even before calling the agents, because obviously in this case, as I said, I only have 2 agents, Neo4j agent and LLM agent. You could have 10 agents, right? And so in here, that's super important because this is going to tell you for what part of the question we created the task and for that task, which agent we called. So in this case, we called the Neo4j agent for this task and why we call it. That's why you will see the strategy here, right? So already just to try to understand from a question what agent we called for what part of the task and the description and the tools used, that's already super helpful, right? Now, obviously, the different agents here, the Neo4j and the LLM agent, they use input from the planner, of course, because they need to get the task, but then they can also obviously collaborate with each other. So you can see here the LLM agent was assigned a task. So the task was this description coming from the planner. You can see the full input. And then you can also see the result, right? So the result, this is the generated output from the LLM, basically, that is going to be used to generate and summarize the response. What I was saying earlier, if you have a Neo4j agent, which is kind of like a GraphRAG agent, you will have the same structure. So you have the task assigned to an agent, and the task will basically produce a result. But then if you use a GraphRAG, what will happen is, because it basically collects data from your graph, you will have this kind of GraphRAG retrieval, which is basically showing you the data retrieved from your data graph, from your business graph. So you can see, for example, to answer this question, the Neo4j agent accessed this document, those entities, and all of that. So that's quite good, obviously, for traceability and all, and audit. You can see who accessed what, right? Now, it doesn't stop here. Basically, what I want to show you is, maybe I'm going to run a small example up. I'm just going to copy paste the same question here just to show you what it looks like for the repeatability, right? So if I copy paste the same question, what's going to happen is, obviously, you have the supervisor here who is going to try to break down this question into multi-part. You have the planner who is going to create a plan, and then you will have the agent code based on the task provided by the planner, right? And they're all going to work together on that. And then we're going to get a generated response. Now, what I want to show you here, because obviously I'm raising the question here, is basically, if I go back here to the planner, there you go. So you have the planner here, which is assigned with a task, an input, and then you have the plan here, the full plan, right? Because you have access to all of that, what you can do is basically you can put some full text indexes or a similarity search on this graph, right? And for the repeatability aspect, when you get a question, which is this question, for example, when you do the breakdown, when the planner is doing the breakdown of this question, right? What you can do is you can use this full text index on the full graph to say, okay, have we already answered this question? And if we haven't, have we answered a part of this question? And so what you can do is, if yes, we already answered this question, or if we answered a part of this question, you can basically go back to this audit graph, get the plan, the execution plan, and reuse part of it, because then you already know that for this question, you're going to save some tokens and obviously some execution time, and you're going to be better on the repeatability, because you're going to be able to say, to generate this answer, which was a good answer because there was a vote or something like that, we basically use this agent with this task, and so you can reuse that basically. So that's mostly it, and I think it's time for Q&A. From Guru, can you please show one specific use case? So yeah, so obviously, we do have lots of use cases where we use that and have implemented this at customer, but most of the time basically is where you have multi-agentic system where think about pharmaceutical, financial crime services and all, where you need to collect data from different sources, and you will have some agent calling API through tools, some agent calling SQL to get some data and all. And this basically helps understand where the data came from, where basically. Before, because I see the time is running out, before I answer the last question, I probably just want to show you the last part, which is obviously the links here. So I would suggest to take a screenshot. I think the decks are going to be shared as well, and this is recorded, so you can always find it. But basically, the first link is the GitHub repository containing the whole obviously code here. And what I was mentioning earlier for the UI part, this is a link to what we call the Needle Starter Kit. Just going to take a couple of minutes here just to show you what it looks like when you're going to head over to the GitHub repository. So you have the backend and the front end. The front end is the Needle Starter Kit. If you want to run it locally, the steps are really easy. You can just create a Neo4j database. You can import this dump dataset, which is just the movie database with embeddings. But again, you can plug it on the database. This is just to help you get it running faster. And then you just need Python 3.9.6 or latest. You can just go into your pack and run the main. Obviously, you will need to create some environment variable to connect to your graph, but that's basically it. From Rajan, what's the interface between agents and Neo4j? How does Neo4j track MCP agentic access? Good question. So I will try to answer that one in 3 minutes or less. But basically, in this case, for this demo, you can see if you head over to the backend that I'm using a line graph for the whole agentic process, right? And that's basically also how basically I collect and trace all the metrics and the logging aspect. Now, how the interface between those agents, the line graph and Neo4j, you can see in the backend, which I can show you now. Basically, I do have up in the app, you have agents here. So that's where you would create your own agents if you want to have more agents. That's quite flexible and modular. You can do that. But the whole audit part, so like storing it back to the graph, that's where you have it here in the audit. You have a Neo4j audit a Python script here, which is taking care of basically the output of all the agents and trying to map them into a graph. So yeah. Oops. Okay. Do we only get this traceability if this tooling is integrated in our own AI application, or is it possible to instrument existing AI tools in org? So I'm guessing here you are asking whether we can have this traceability as part of other tools, things like GPT, Claude, and all. So yes, so I mean, as you said, or as we talked earlier, right? You can obviously customize it as you wish. You can have your own agents here, and you can have some extra layers on top of it. And the way you would achieve that would be basically with MCP. Yeah. So this is basically the core backend layers that would be basically running on your servers. So you would still need to run that on your server, right? But then on top of that, you can have your own MCP and think about this audit part, right? This audit part is basically just collecting the output from each agent and just trying to map them into a graph. This can also be done in an MCP way. So it can be plugged into Claude, for instance, or anything else. And I think we're just right on time. Maybe I can take this one just before we shut down everything. So agents are storing their logs to be later picked up by Neo4j. Yes, exactly. All the agents, all the workflows, or everything basically is stored in Neo4j as a graph. So you have the whole orchestration workflow stored in Neo4j. Thanks, everyone. And I hope you enjoyed the next session.